This is a lesson for Year 9 Higher Mathematicians on summary statistics, and this is lesson 1, the mean and range from a frequency table. The number of goals scored by each of the 20 Premier League teams in one weekend is recorded below. Place the unsorted data into a frequency table. Explain how to use the table to find the average number of goals scored. So what we're going to start out by doing is putting this data here into the table. While the lowest number of goals scored was 0, and this goes all the way up to 5 goals scored. Now what I need to do is to record precisely how many teams have scored 0, 1, 2, 3, 4, 5 goals. And I'm going to do that by tallying. So for the first value then, we've got 5. I'm going to put a tally in here, and to make sure that I don't get confused and accidentally record the value twice, I'm going to cross it off as I do that. So 1 goal, I put a tally here, 3, 0, 1, 2, 4, 1, 1, 2, 0, 3, 1, 0, 5, 4, 0, 1, 3, and 0. Now, those tallies will be quite difficult to look at if there are a lot more of them, and to see at a glance how many teams have scored those goals. So what we do is we turn those tallies into a number called the frequency. So here, this tells us that 5 teams scored 0 goals on this particular weekend. So the frequency is 5. 6 teams scored 1 goal, 2 teams scored 2, 3 teams scored 3, 2 teams scored 4, and 2 teams scored 5. Now, when you've only got 20 Premier League teams, creating this table is fairly easy, and you might almost say, what's the point of actually sorting the data into a frequency table? But we're not doing it for these 20 teams. Okay, in actual fact, it's for when we've got 100 pieces of data, 200, 500. Okay, trying to manage that much unsorted data is very difficult. And so by putting it into a frequency table, it makes it more manageable. And how do we use the table to find the average number of goals scored? Well, that's what we're interested in today. So looking at this example, the frequency table shows the times taken to the nearest minute by runners in Athletic Team A to complete a 3.575 kilometre race. Find the mode, the mean, and the range. Now, hopefully we know that the mode is the most common data value. And as we can see from this table, if we look at the frequencies, you can see that 5 people took 25 minutes to complete the race. So that means if those 5 people took 25 minutes to complete the race, that means that the mode is going to be equal to 25 minutes. Now, to calculate the mean, we have to add up all the data and divide by the number of pieces of data. So rather than go through and add up all these times individually, what we can do is use this table to speed things up a bit. So we have got here 23 minutes. Okay, 2 people have taken that time. Okay, so 23 times by 2 gives us 46. Here we've got 3 people who've taken 24 minutes. So 3 times 4, 24 is 72. 5 people who've taken 25, so 25 times by 5 gives me 125. 26 times by 4 is equal to 104. 27 times by 3 is equal to 81. 28 times by 2 is equal to 56. 29 times by 0 is 0. And 30 times by 1 is 30. Now you'll notice I've used some mathematical notation here, okay? This here, f of x here. Okay, well what this actually means is, this symbol here is the sum of fx. So if this column here is x, that's the time, and the frequency is f, well that multiplied by that is f of x. And the sum of f of x, okay, is basically just this column added up here. So if we were to add up, in other words, all the times that the runners have taken, we would end up with 514 minutes. Now we know that to calculate the mean, we're going to have to do the total sum of all the times divided by the number of runners. At the moment we don't know how many runners there are, but if we add up all the frequencies, the sum of the frequencies, then this comes to 20 runners. Therefore, to find the mean, all we need to do is 514 divided by 20, which gives us a value of 25.7 minutes. Now the range is the difference between the highest and lowest values. Well, the highest value in this particular case is not 5, okay, it's actually 30 minutes. Okay, and a lot of people get confused when they're trying to calculate the range between which column they need to use. It's always the value of the data that you have. It's always using the values of the data, this column here. So the highest value is going to be 30. The lowest value is 23, which gives you 7 minutes as the range. Now, what we want to do is to use these summary statistics that we've calculated to compare Team A with Team B. Now, I've already completed the summary statistics that we've just calculated here for Team A. And to make a comparison between Team A and B, we need to use a measure of location and a measure of spread. Now when we say measure of location, what we mean is an average, okay, a single value that represents all the data. I'm going to use the mean in this case, and if I have a look at the mean of Team A compared with the mean of Team B, you can see that on average Team B are about 1.7 minutes quicker per runner than Team A. So that is my first comparison. I'm going to say something like, on average, Team B is 1.7 minutes quicker than Team A. So that's my comparison of the measure of locations. So the measure of spread then tells me which teams had the most varied times, which times were the most spread out. Now if you have a look at Team B here, the range is 11 compared with a range of 7 for Team A. That tells me that the runners in Team B, the times were more varied. So that's what I'm going to write. So the times for Team B were more varied than Team A. Now, you could say the same thing, just rearranged in a different way. So, for example, you might say the times for Team A were less varied than Team B. You might say that on average, Team A is 1.7 minutes slower than Team B. But as long as you make those two comparisons, the measure of location, which you do using an average, and the measure of spread, which you do during the range, okay, you will fully answer any compare question.